We will be looking at hypothesis testing and one specific example, which is a two-sample test of hypothesis dealing with dependent samples. Just very briefly, a hypothesis is a statement about a population. What we have is data is used to check the reasonableness of the statement. For example, a person is innocent until proven guilty. The hypothesis is that he is innocent, and the jury now has to check the evidence and hear testimony before reaching a verdict. When you buy a half gallon of milk, you assume that the container has half a gallon. The hypothesis is that it is half a gallon, but in reality, you're really not sure. It could be less, and that's the purpose what we're trying to do in hypothesis testing. Given a statement which is assumed to be true, we are going to test it, usually by taking some samples or possibly many samples, and to see if the original statement is true based on the sample result. We're going to look at a t-test. How is this used? Let's give the following scenario. There's a company that makes shirts, and they feel that these shirts are better than the well-known brand that is sold in the high-end stores. The shirt that is the discounted shirt is called Bedora shirts. And we'd like to perform a statistical test to see if in reality there is a possibility that they are really better. So we have a statistician prepare a bunch of questions whereby we're going to have them evaluated by a sample of people. And we're going to choose 10 people initially and have them wear one shirt, and then we'll have them wear the other shirt, and we will see their ratings for each of the shirts. Let us take a look at how we are setting this up and how we are going to analyze it. What we see on the screen are the results of 10 people, call them sample 1 through 10, and they have given scores to the shirt of the Bedora brand and the well-known brand. So for example, sample 1 gave a total of 235 points to the Bedora brand based on certain criteria that was presented that he or she had to answer, and the well-known brand received 228 points. Sampler 9, for example, gave the Bedora brand 225 and the well-known brand 222. So what we'd like to figure out is how does the Bedora brand compare with the well-known brand? Is it better? Is it worse? Is it the same? And for this, we're going to perform a t-test. Specifically, we're going to perform what's called a paired two-sample t-test. Now, a t-test is used to determine whether the means of two sets of samples are equal. However, in this case, we're going to be using a paired two-sample t-test because there's a relationship between one and the other. The same sampler is trying on the Bedora brand and the well-known brand. If we happen to have 10 people for the Bedora brand and a different 10 people for the well-known brand, then it would not be a paired test. In order to do this, we go to Excel and we go to Data, and we're going to choose Data Analysis. And if you notice, we have a few tests for T. There's a two-sample for means paired, which we're going to be doing, and there are two others which we will not be looking at this point. The t-test as an aside, is typically used when we have a sample size of under 25. And here we just have 10. Let's continue. Let's press OK. And it asks us, where is the data located? Well, let's highlight the data, which is Fedora brand. That's in cell B1, or B2 really, to cell B11. And let's go to the well-known brand, and we highlight cell C1 down to C11. And it says, what do you hypothesize the difference to be? Well, if we are testing if there's any difference whatsoever, we're going to hypothesize that the difference is 0. We have to decide on the alpha value. Let's put in 0.05, which is the default, but we can change that. And let's click on OK. Immediately we see our response, we see the results. Let's expand the columns and let's do some analysis on this. First of all, we see that the mean of the Fedora brand seems higher than the well-known brand. We see also the variance is higher as well. There were 10 observations. Let's go down to look at the important values. One of them is the t statistic, which is given as 3.3. And for a two-tailed test, which we are conducting right now, the p-value is 0.009, which is quite low. And because this p-value is less than the typical value of 0.05, we would, as we say in statistics, reject the hypothesis that the mean of the distribution of the differences between the two brands is 0. What this means very simply is that yes, it does seem that there is a significant difference between the Fedora brand and the well-known brand. And if we had to guess at this point, we would say it seems like the Fedora brand is better. But we would have to pursue this further. We are not going to go into the details of the statistical analysis, but I do want to review one or two important points based on what we did in order to arrive at this conclusion. First of all, we applied what's called the paired sample test. And it's called paired sample because the values that we obtain depend on or are related to the sampler. So for example, sampler 1 wore one shirt and then he or she wore the other shirt. So the sample is related to what's called a before and after, or one type and another type. The second point is we tested whether the distribution of the differences in their scores is 0. Now, one sample result could have a answer if the two shirts would be similar. Then sometimes we'd find that one would be rated a little bit higher, one would be rated a little bit lower. And overall, the mean of the distribution of the differences will be 0. On the other hand, if one of these shirts consistently reports a larger value, then we will say, as we have found here, that the mean of the distribution of the differences is not 0. And that seems to be the result here. Now, to go on from here, we would have to consider increasing the sample size and looking at more information. But this is a very good beginning step.